Professor Philip Yuan, thank you so much for taking the time to contribute to Additive Dialogues. I really appreciate your contribution. Can you tell us a little bit more about yourself and introduce your position at the Archi-Union and at Tongji University?
Okay, it's my pleasure to have interview with you. My name is Philip Yuan. I'm based in Shanghai, the full professor, tenure professor in Tongji University College of Architecture and Urban Planning, as well as I founded a design office named Affiliation in 2004. Actually, we have a led practice over the past 20 years, a special focus on the computational design and the robotic fabrication. More or less, we already finished more than 30 projects, and most of them implement robotic for special toolbox. And the robotic fabrication is more about not only the decoration facade, but also goes all the way to the structure, just like this tower. So actually, I founded Archi-Union as a design office, as well as Fab-Union is a robotic fabrication office in Shanghai. So Fab-Union is a robotic fabrication team. And right now they have over like 30, 40 people, and also around 30 robotics, which is a very big city robotic fabrication factory. So that's helped us to actually introduce the new technology all the way to the practice.
And how did your background as Professor Philip contribute to your fascination with the digital toolbox and computational design? How did that journey come to be?
Yes, I advocated as an architect. I think digital fabrication is like the new concept which emerged from the beginning of the 2010. So over the past 15 years, after I came back from MIT as a business scholar, I established the digital factory from 2011. And I think that I start to implement the programming into the design process, the computation design. But after we design some object, it's difficult to construct it. So we need some new toolbox like the CNC and the robotics. So from 2011, we established some like the laboratory inside the Tongji campus. And from 2016, we start to I started to found it Fab-Union. So more or less it's around nine years. So they emerged to be a city factory which have very close relation with designers.
You spoke about how Archi-Union was founded. Can you tell us what does the name represent in terms of the ethos of the practice itself?
So at the very beginning, Archi-Union represents, because I'm teaching, I have some like PhD students and the various students. After their graduation, they like to engage into the practice. So it's like a team up, it's like educated in Tongji and my student and working with me after their graduation. So it's like a team. A team is from the knowledge all the way transferred to the real practice.
And that forms the union.
The union, yeah. So Archi-Union is more about the architecture design, the Fab-Union is more about the fabrication as a team.
Can you tell us a bit more about the Nanjing Gate, specifically, and also Venue B? How did computational design processes contribute to these projects to overcome certain challenges? And how did 3D printing in particular also contribute to certain challenges, specifically, for example, with Venue B completing the project in under 100 days?
Yeah. For example, in a Nanjing project, we got the invitation to design the theme park entrance during the COVID. During 2020, all the workers, it's impossible to work in like a team, working together to build some special project. So the developer invite me, if it's possible, to prefab something in your factory and to install them super efficiently on site. So I told them it's okay. So we generate a special geometry form as the main entrance for the theme park. So we fabricate all these panels. It's around more than 4,000 pieces of the panels in the factory. around 3 months. So I think it's the earliest project to introduce the 3D classic printing in such a real scale project. So we finished everything in 2021. So all the project, including the structure system, only spent like 5 months and a half. So it's super intense. So at that time, we implement like ABS as a special material to the auto space. But it's still a lot of challenge. Or at that time, we need to do a lot of tests in the lab. I think this is actually one of the first one. But actually, in 2018, I introduced the spatial printing in Venice Biennale,
Nice.
China Pavilion. So it's
Spatial printing.
it's really it's like it's not a counter print. It's like a matrix
Yep.
printed. So
Almost like a voxel.
yeah, voxel system. The voxel system represents just not just the geometry, but also based on the performance based driven by structure performance based driven, because we actually implement the BSO, which is in my direction optimal topological optimal formation, which takes away the waste material. It's which based on the density. The more dense part is the structure, and the less dense part is the transparency as a space. So that's whole object, the pavilion in Venice, is based on the structure performance simulation. The Vanity project is, I think, to integrate different robotic fabrication, including timber as a shell structure, and also we design the voxel spatial printing by robotic classic printing. And right now we have another project going on, which is Yuan, which is nearby Beijing. It's a conference center, and all the facade system is around 15,000 square meters. The whole project, and the facade is also painted by classic. So that is, I think, one of the biggest projects around the world to implement the classic printing. So we collaborate with classic scientists, material scientists, to develop the certain environmental materials which can maintain at least 20 years for all those structure. Yeah.
In the Middle East, the Majlis is a culturally relevant space, space of gathering and conversation. Similarly, in China, there's also the tea house. And the tea house is also a place of gathering, of ideas exchange, conversation. Can you tell us, how did the tea house that Archi-Union designed, how did you juxtapose contemporary ideas and technologies with more vernacular thinking or traditional methods of construction, and also thinking of space from Chinese culture? And how was that exchange happening between the past, the present, and the future?
It's a very good question. Actually, I think I put forward the idea as a global design methodology in all my projects. So the global thing is like more the technology part. We introduce competition design robotic fabrication as a global technology, which is general type of technology. We develop the softwares, hardwares, and open source to all the users actually on the GitHub. So that's what we believe in. This kind of universal or the general technology can help more people in their labs and also money tactics. So that's what we have done over the past 50 years. And secondly, I think the local culture there is like tea house. I designed a tea house in 2009 because in Chinese culture, every family or office will have a tea house to interview, to meet your clients and your friends, right? So it's a cultural space. In Japan also, you can see different cultural space like this, which is super local culture. It's embracing by the bamboo forest, and also have like a tea house outside all those ponds. And the inside space should be like a more coming down space, and people talk to each other. So I introduced the formation based on we keep the original tree, which is a super big tree, inside the key house. We surrounded by the concrete, and all this kind of circulation and the geometry is like guiding you all the way, not only surrounding the trunk, but also all the way to the branches. So embracing the branches. So it's like a geometry with the environment. So we generate the form but actually how to fabricate is based on the roof surface panels. So the timber is a panels to support all the geometry, and then we part concrete on that. So it's kind of a local technology with a combination with the geometry formation system. So it's the strategy is clear in all my practice. We have both the normal general methodology, which is global, like spreading through the workshops, researchers, studios, as well as we implement local culture, local material. And also, I think design is not just about the object itself, it's about the relationship between the object and the environment. So it's kind of pati. We name it as a kind of pati. It's kind of gesture, the geometry with the environmental system. So that's what we are doing. So analysis from the environmental design, but all the way to the formation process and to the fabrication process.
Was there any modular kind of logic in the way that the tea house was conceived or constructed?
I think it's from the model making with roof surface geometry. We have 1 to 5, 1 to 2 big model and teach the workers to figure out the geometry formation. We make a lot of drawings, but the drawing is too complicated, the sections. But the model is very clear.
Yeah.
So then help them to find the roof surface, which is a linear part, and how to linearly set up the mold system, how to put concrete on that, and also introduce the structure engineer, how to calculate the structure system.
Yeah.
So it's all about process design.
Yeah.
A process design is based on a computational design, and also introduce this kind of integration of the fabrication. We need to design the fabrication process.
Yeah.
So that's the super important part. So after, based on this kind of low-tech technology, we start to learn how to use robotics, how to program robotics. So it's kind of also design the process. The design is not just about the object, the design, the formation and the fabrication process.
And on that note, if you were to redesign that process or redesign the tea house, would you integrate 3D printing in a way to kind of rethink these processes and construction methods?
Yes, actually, we have just finished a bridge in Shanghai last year, which are about 60-meter span, and the net span is around 40 to 45 meters. So it's kind of modular system. We need to design the process. It should be modular, prefab fit, and we put them out. The big project is not in situ design sometimes because it's limited by the environment. If you have trees, it's difficult to put all the machine into the construction site. So normally we introduce the prefabrication technology into the roof project. So I think after the tea house, the sequence of design we practice over the past 15 years. We design like 3-4 buildings like tea house. But after that, we try to introduce the prefabrication, to implement the concrete printing into the big scale project. I think which is like the evolution of our methodology practice.
In conclusion, can you summarize how could new novel technologies like 3D printing contribute to improve the quality of life?
I think 3D printing is kind of custom design. The design in the future is, on the one hand, could be some very big design firm as a teamwork. They can design super big project. And on the other hand, we have like very small scale design work, including the furniture. I'm teaching a studio on furniture design right now. And we teach my student how to print it. It's kind of chairs. And you need to learn the way of thinking from the machine intelligent perspective. It's not different. It's not same to the human fabrication. As a researcher, I try to develop the platform for that. As a designer, I try to figure out how to design based on such kind of machine thinking, machine process. I think it's the future. The designers, it's not just a human body, it's kind of the human machine carried future. So I name this as a co-poesis future in Municipality this year. So I will introduce how the human and humanoid, also human and the robotic fabrication, you can collaborate as a team, as a new like the human-centric, but this human-centric is kind of human-machine agency, co-agent platform. to develop some new features for the architecture testing.